We shall now consider the second example for the single source shortest paths, Dijkstra's algorithm. So consider this second example, directed graph, right? So the Dijkstra's algorithm works for both directed and undirected graph. Okay. So in this case, so as you can see, there are 6 nodes, and this is the source node to be considered, and these are the weights of different paths. Okay. All right. So the tree vertex first to be considered is the source vertex, that is the vertex 6. The vertex 6 has no next to last node, and source to it, the distance is 0. Okay, right. The remaining vertices we have to write. So for the vertex 1, is there any direct edge? No. Vertex 2, is there any direct edge? No. For vertex 3, is there direct edge? No. Vertex 4, is there any direct edge? I mean from source to that, right? Yes. So 6 is the next to last node, and the cost is 4. Next, for 5, is there any direct edge? No. All right. So now we have to choose the minimum. Okay, minimum. So anyhow, for this node we have only one fringe vertex, and that itself is the minimum. Therefore I will choose 6 for edge with the cost of 4. Okay, all right. Now the next to be considered is the node 6, that is reached from 6 with a cost of 4. Now for the node 4, you have to find all the fringe nodes. Which are the fringe nodes? So fringe nodes, I mean from 4 to which all other nodes we have a direct edge. We have a direct edge to 2, we have a direct edge to 5. Therefore in this iteration, the the values for 2 and 5 gets updated, isn't it? Okay. So 1 as it is. Then for 2, so the 2 is reachable from the source node with a cost of this cost. 2 is reachable from the node 4 with a cost of 4 plus cost from 4 to 2, that is 4 plus 10. Next 3 as it is. Next 4 is already considered. 5, so 5 is reachable via 4 from the source node with a cost of this 4 plus this cost. I mean from 4 to 5 the cost is 35. Okay, so this is 39 and this is 14. Therefore among all the fringe nodes, which is having the minimum, this is the minimum, and we will have to consider this in the illustration, and we have to add that into the tree vertex. So I will add 2 is the destination node, that is reachable from the source node with 4 as the next to last node with a cost of 14. Okay, so 6, 4, then 2. Okay, right. Now from 2, which are all other fringe nodes? So it is 3 and 5. Okay, 3 and 5. So in the next iteration, 3 and 5 will get updated, isn't it? So 1 as it is. 1 is still not reachable from the source node. 2 is already considered. The next is 3. Is 3 reachable? Is 3 reachable from 2? Yes. What is the cost? This is 14 plus this cost is 15. Total is 29. So what is the earlier cost? Infinity. So anyhow 29 is less than infinity. So 3 is reachable via 2 from the source node with a cost of 14 plus the new weight, that is 15. Similarly node 5 is reachable. Is it reachable from 2? Yes. What is the cost? So cost is 14 plus 20. How much? 34. What is the existing cost? 39. So which is the lesser value? 34. Therefore we will update 5. So 5 is now reachable via 2, not from 4, from 2, with a new cost of 14 plus 20. Alright. Then, so this is 29 and this is 34, which is lesser value 29. So I will consider this edge, that is 2 to 3. Okay. So in the illustration it is 6, 4, 2, 3. Done. So in for the next iteration we will add 3, that is reachable via 2 with a cost of 29. Done, with a cost of 29. Now is 1 reachable from 3? So for 3, which are the fringe nodes? That is 1 and 4. So 4 is already considered, therefore we will have to update for 1. 1 is now reachable from 3 with a cost of this 29 plus the cost from 3 to 1, that is 10. Next 5, still it is there. Is there any edge from 3 to 5? No. So 5 as it is, that is 2 comma, it is 34. Okay, 2 comma 34. So 34 and this is 39. So this is the lesser value, therefore we will consider the edge 2, 5. We will consider the edge 2, 5. 6, 4, 2, 3. Now we will add 5. Okay. Next, the next edge to be considered is this, that is 5 is reachable via 2 with a cost of 34. Okay. Next, is there any edge from 5 to 1? No. So of course for however for 5 there is a fringe vertex, that is 4, but 4 is already considered, so we are left with only 1, that is reachable from 3 with a cost of 39. Okay. Therefore we will have to consider this as the last. I will add the edge 3 to 1. Done. So 1, 3 comma 39, nothing, and this is the tree, and these are the shortest paths. So we will write the table now. Node, then path and length of the path. Okay. So node 1, 2, 3, 4, 5. Source node is 6. Right. So first consider the node 4. So node 4 is reachable via from 6. Right. So it is path is for the 4, it is 6 to 4, and the length of the path is 4. Done. Next node is 2. 2 is reachable from 4. So 2, the path to 4 is 6, 4, and then it is 2, and the cost is 14. Next 3 reachable via 2. Therefore for 3 we will write the path to 2 first. Path to 2 and then 2 to 3, and the cost is 29. Next 5. 5 is reachable via 2. So path to 2 is 6, 4, 2, and 2 to 5, and the cost is 34. Next 1, it is via 3. The next to last node is 3. So for 3, what is the path? 6, 4, 2, 3, and then 3 to 1, and the length is 39. So these are the shortest lengths.